In this video, I'm going to do a deeper dive into lists. We've discussed briefly what they are in the past, but let me start by reminding you. So a list is a collection of objects that are ordered. So it might be something like list of numbers equals 1, 2, 3, 4, 5. So we could have a list of integers, and here I'm storing it in a variable called list of numbers. And we don't have to use integers for this. We don't even have to use all of the same type. We could have something like mixed list equal to 9, which is an integer, 8.88, which is a float, and cow, which is a string. So let's talk about what things we can do with these. Oh, before I do that, one thing to always keep in mind with lists is they have these square brackets at the beginning and the end. There are similar looking things called tuples, and they have a parenthesis at the beginning and the end, and they behave differently. It does have to be marked with these square brackets if you want to work with lists. Specifically, a thing that makes lists unique compared to something like a tuple is that they're mutable. And what I mean by that is I could change the values in my list. So let me show you how we can change the values. Before we do that, I have to show you how to access the different items in the list. If I do list of numbers, and I put the number 1 after it in square brackets and hit enter, you can see that it's given me the value 2. And that's because it's pulled the value, the corresponding value, off of this list. When we have a list, the first item in the list is always the 0th value, then the second item is the first. That's why when I did list of numbers at 1, I got 2. It's a little bit confusing because you would think, oh, the first item should be the first thing in the list, but not in this case because we start counting at 0. Then if I were to do something or try to pull the value 3 off, I would have to do list of numbers 2, and we would get 3. So the numbers are 0, 1, 2, 3, and 4. Similarly, if I go to mixed list and I looked at the first value, I put a 0 in square brackets, we get 9. If I put 1 in the brackets, we get 8.88. And if I put 2 in the brackets, we get cow. So again, same numbering for all lists. Now, if I try to put something like 3 in the brackets, it's going to give me an error. So that is a possibility if you're working with lists, that if you number them wrong and you think, oh, 1, 2, 3, or you just, accidentally put the wrong input, wrong variable or something into the index for the list. So this is called the index, the 1, 2, 3, and so on. Then you will get an error. So you do have to be careful. And if you put something in the square brackets that exceeds the number of values in the list, you'll get an error that says list index out of range. So if I look at list of numbers at 1, I'm saying I'm looking at the list of numbers at the index of 1. So here's our list. Now I said they are mutable, and I had to show you how to access things in the list first. Say I want my list to now say 1, 100, 3, 4, 5. What I could do is I could say list of numbers at 1 that currently equals 2, and I'm going to change it to 100. Now, if I look at my list of numbers, it says 1, 100, 3, 4, 5. So I've been able to change the value. Also, if I look at mixed list at 2, and I want to change it from cow to cat, I can. I just set it equal. And then if I see mixed list, then it'll change cow to cat because I've given it a new value. I can also change mixed list at 0 to cow. Even though mixed list at 0 is currently an integer, it's the value 9, I can change it to cow, and we have this. Another way that we can index lists is actually using negative numbers. Let's get our list of numbers back. We can look at it for reference. If I look at list of numbers, and now I'm going to look at this at -1, which seems wrong because if it starts at 0, you would think maybe -1 will be out of range because it's too small. But when you put a negative index in, it starts reading from the back of the list. So if I do list of numbers at -1, it gives me 5. If I did -2, it would give me 4, -3, -4, -5, and so on. List of numbers at -5, that gives me 1. And we can run into the same problem where we go out of range here. So if I go to -6, which isn't here, then because it only goes to -5, then it's still going to give me an error. So generally, using negative numbers isn't as useful of a technique, but something that I find I use the most often is lists of numbers, or like lists at a -1 value. And that's because sometimes you just want to know the last item of the list, or you just want to change the last item of the list. And instead of trying to figure out like, what index the last item is, especially if it changes as your program executes, as it runs, it's easier to use -1 because we know it just always refers to the last item of the list. Let's take our mixed list again. Say I want to make a new list, new mixed list. This is something I see come up a lot. We want to say, oh, let's make a new copy of this list. Then we have new mixed list. That's just equal to what mixed list was before. Same as assigning any other variable to a value. So new mixed list is cow 8.88 cat, and maybe I want to change that first value to duck. I'm actually going to create a string y equals duck, and then I'm going to say new mixed list at 0 equals y. What I'm doing here is I'm taking the first value of new mixed list by using the 0 index, and I'm setting it equal to y, which has the value duck. So I partly did it this way just to show you that we don't have to explicitly say what the value is here. We can use a variable to set the value. And in theory, this variable will set the value at the beginning of the list to duck. So let's look at new mixed list, and it's duck 8.88 cat. Now let's look back at mixed list. Mixed list, you can see, also changed when we changed new mixed list. So new mixed list, we changed the first value, and then when I print out mixed list, first value changed to duck as well. This can be problematic because sometimes you want to make a copy of a list, but you don't want to change the original list, you just want to make changes to the working copy. If you ever want to make a copy of a list, I can do list of mixed list. So by putting this list around it, now if I say new mixed list at 0 equals, and then I change it to hairbrush, then new mixed list is going to behave how we would expect. So new mixed list is here, hairbrush 8.88 cat. But now if I print mixed list, we can see that mixed list has not changed. So the distinction here is that if I use the word list when I'm copying the list over into a new variable name, if I change the contents of that new list, I'm not changing the contents of the old list. However, if I don't use this word list, if I don't put this wrapper around mixed list, then whenever I change new mixed list, I'm going to change mixed list as well. So this is something to be careful of, and this is important because I could do something like x equals 5, y equals x, and then I could say, well, let's make y equals 6. It doesn't happen when I do this with integers, right? Like I don't have to do some sort of wrapper to make sure that when I change one value, the other value doesn't change, and so on and so forth. It's just the thing with lists where if you make a copy and then you change one value in the copy, it changes it in the original. That won't happen with any other variables, like, well, any of the other basic variable types we've talked about, like integers or floats or whatever. This is the whole point of this is how you copy a list if you want to make sure that you're not changing the original. We can also make a list with nothing in it. If we just use a set of square brackets like this, empty list equals, then it's a list with nothing in it. I could also say empty list 2 equals list. This is another way to make a list with nothing in it. So just using the keyword list. This is called the constructor function for the list. You don't need to remember that right now, but yeah, these are just two separate ways to make an empty list. An empty list might seem kind of goofy, kind of like, a list containing one item might seem kind of silly because then you just might use a variable, or with an empty list, like literally no point because it doesn't have anything. But sometimes you want to start with an empty list and then you want to put things in it. So maybe I have something like a student list and the semester hasn't started yet, so I don't know who's in my class. And then John Doe enrolls in the class. I can do something like student list dot append John Doe. So this append function adds something to my list. So if I do student list dot append John Doe, then we get something in the list. And then I could do student list dot append Rachel Ratch. And then if I print student list, we can see it has John Doe and Rachel Ratch in it. Usually when you make an empty list, it's not obviously for the reason of just keeping an empty list around, but it's something that as your program runs, you might want to fill the list with values, and you don't necessarily know what all the values are going to be before your program runs. So something like this, I'm showing you just like the one line of how do I add something to a list, but you could have some more complicated logic where someone's typing in names into some form and then the list will pull in the typed input and append it to a list. There's different ways that this can be used while the program is actually running, and you don't want to just set it up before you run the Python code. So in addition to the append function, we have the insert function, the remove function, pop, sort, and reverse. That sounds like a lot. So let's start with the easier ones. If I do student list dot reverse, it's going to just reverse what we have in the list. If I do, let me make a numbers list. 4, 7, 88, 9, 5, 111. Okay. Say I have a numbers list and I went ahead and reversed this. You can see again, it's just taken the last element, made it first, and completely flipped it around. There is an insert function as well. So if I do numbers.insert and I try to put the number 7 into it, it gets confused. It expects 2 arguments, it gets 1. So let me say numbers.insert 1 or 7 comma 1. What we can see happened is a 1 was put into the list. I maybe should have printed numbers before that. The clear function actually just moves lines down far enough you can't see the previous output. So before my list was 111, 0, 3, 5, 9, 88, 7, and 4. So you can see that there's no 1 in this list right now. Also, let's count up the indices. So this is 0, 1, 2, 3, 4, 5, 6, and then right here the 4 is at 7, position 7. So when I say numbers.insert 7 comma 1, it's going to look for the 7th position and insert a 1 in there. Previously it went 7 and then 4, and 4 was at the 7th position, but now there's a 1 added into this list in front of the 4. And if I did this again, actually numbers.insert 7 comma 1, let's do it 2 more times, it's going to keep inserting at that position. So this is the first one that was inserted, then this one, and then this one. And the other ones always get pushed back. If I do numbers.insert 7 comma 2, you can see that the 2 got added in front of the 1s because that's now the 7th position. We can also sort numbers.sort, and then if I show you numbers, it's going to sort the numbers from lowest to highest. If I say numbers.remove and I tell it to remove 0, you can see it took the 0 out of the list. What happens if I try to remove 1, because there's 3 of them in the list? What will it do? So if I do numbers.remove 1 and then print out numbers for you, you'll see it only removed 1 once. So if I have 3 1s in the list and I want to remove all of the 1s, I have to do it 3 times. Right now we still have 2 1s left, and if I do numbers.remove once 2 more times, then all the 1s are gone. So each time it only removes 1 thing. Now, if I try to remove 1 again, it gives me an error because the number 1 is not in the list, so it can't find anything to remove. You can only use this when the number or when the value you're looking for is actually in the list. There's also the pop function. So if I do numbers.pop, you can see that it returned for me. It gave me the value that was at the end of the list. So it actually took the value off the end of the list. it also does this additional thing where you do numbers.pop. It's giving you the number from the end of the list back, and that's just in case you want to store that and use it. If I do x equals numbers.pop, then the last value is removed from the list, but I can still store that value in x if I wish. Or I could just do numbers.pop and not use a variable if I don't care about what that value was. So those are many of our list basics. We talked about indexing, we talked about various functions, including append, insert, remove, pop, sort, and reverse. And we just talked a little bit more. We talked about how to copy lists, and we talked about the mutability of lists, the fact that we can change the values that are actually in them. There is, of course, more to know about lists. There's always more to know, but this gives you a good foundation to start working from, and I'm putting together these different tools for you so that we can pretty soon, with a few more tools under our belts, be able to start writing some basic programs.